is
This
tracking,
conference will now be
right?
recorded.
So likewise, there will be different types of chips. Each chip will be having its own application specific. So we call this as application specific integrated circuit flow, which means where does the design of a chip start and where does the manufacturing stands within this flow. So we will see a flow chart kind of thing that will explain the flow of the chip making or integration in a overview, in a global overview. We will not go for in-depth of details, and we are going to see only the one part of the flow. There will be too many number of other categories also, like the manufacturing process is not listed here. Only the digital or the analog, whatever we have, the designing part, the implementation part is what we are going to see. The manufacturing part we are not going to see. Only the designing part and the implementation part, how does the flow looks like, is what we are going to see. Okay, so this is the entire flow. Let me start with the first one, which is design specifications. So any chip, any engineer, any company who want to build a chip should clearly understand what chip they are trying to make, for which feature they are going to make, for which specification they are going to make. For example, there can be a company who can manufacture a chip only for smartphones or your laptops or desktops. A chip that can be placed on a motherboard which can be used for the processing unit. So they need to understand the specification first. What all specifications the chip can do, whether it is a processing unit, whether it is a simple amplifier unit, or what type of unit it is, right? So we call them as specifications, a design specifications. So there can be a separate team in the companies who will decide as per the market standards, latest technology. They will try to have the decision here to understand what spec they are going to build. So there will be another team of engineers who will be start writing the code for the specification. So what happens? So the first team has mentioned that, okay, this is the specification we have decided. So for example, a company who is manufacturing a chip for a Bluetooth device activity. For a Bluetooth device activity, a company is going to manufacture a chip. So the specification is working feature of Bluetooth. So the design code engineers will come and they will start writing the code that which works for the Bluetooth feature. So they will start writing a code. Yeah, did anyone enable the mic? Okay. So this team is also called as RTL designers. We call them as RTL designers or RTL design team. So what is RTL? What does RTL stands for? Register transfer logic. So how does the registers are placed? Can you be on mute? I think somebody has enabled the mic. If you're not speaking, can you please be on mute? I don't see a person. Someone is enabled the mic. Attendee 8. I still see your some background noise is coming. Can everyone please keep on mute? People who are online. Is it clear to you? Noted. Okay, fine. Now it is okay. Let me continue. So once the design code has been written, there will be another team who will be doing a validation part. So whatever the code has been developed here, there should be someone who has to validate the code. So there will be a separate team called as verification team who will be doing the validation. So they will be writing something called as test bench. You might have heard about it. What is meant by test bench? So the test bench can be written to validate. It's a stimuli, an input stimuli who can validate the code, whatever it is written. So once the verification is done, now we will have another team. So all these boxes, each and every box will represent a team of engineers, a team group of engineers. So synthesis is another team of people who will be converting the code from one format to other format. So we need a format of the code. So here it is in behavioral Verilog code. So that code will be converted into a gate level structural Verilog code. So both are Verilog only. This is also a Verilog and this is also a Verilog model. So the modeling of the code will change from behavioral Verilog code to gate level Verilog code because we want to see the gates and the flops, how they are connected, right? A gate can be there here like this and gate output can be connected to a flip-flop like this. Okay. So once the synthesis has been done, now comes our into the main part, which is the DFT. So we design for DFT stands for design for test, which means you need some design for testing also. So if you have a chip like this, you cannot simply tell that, okay, test the chip. How do you test the chip? You need to have a additional design. You need to have some additional design in the chip. So a small additional design will be placed. That is nothing but a DFT design. A small box of design will be added in. It's an additional design, extra design what we add into the chip only required for testing. So this design will be responsible for testing, which means it will communicate to each and every module in the design in the entire chip. It will take the response also and it will test the entire remaining part of the chip what we have. Okay. Okay, so now after DFT we have another domain called as physical design domain. In physical design domain, so the layout of the chip will be done here. So we'll have a layout of the chip. Once this up to here the designing part is completed, you can consider like that. Up to here the designing part is completed. So once the designing part is done, now the another set of engineers will come. They will try to do the layout of the chip. So you know what is meant by layout of the chip. So like when you construct a building, you need to have a layout. So in similar fashion for the chip also, if you want to design the entire chip and provide it to the manufacturing, you need to have a layout. Based on the layout only, the manufacturer will do the chip manufacturing. So once the layout has been done, there will be another team which we call them as sign off team, which we call them as sign off team. So what is this team is going to do? They are going to check the timing of the design. They will see the timing, which means the performance of the chip. So earlier, the first part is designing. Second part is the layout. Third part is the performance or the timing of the timing of the design will be checked. So once that is done, we go for the final step, which we call that as tape out. which we call that as tape out. So what is meant by tape out? We are going to give the entire database. So this circle of the block, what you see, we are ready to give the design to the manufacturing. So tape out means the chip can be called as a tape. So you are giving your design out. So after all these steps, we are going to give this design to the manufacturing part, unit. So in this part, if you closely look into it, our DFT comes into the category of designing. Our DFT comes in the category of designing because that is the last part of the step where your designing is being done. So this is the entire part of design phase. So what after this, there will be no more design changes. As per the specification, the designs are fixed. Even it can be testing, it can be specification, whatever it is, the design is fixed after this green color box. So the physical design team will do some modifications to the design, but they do only the layout of the chip. Okay. Can you please keep on the mute? I'm continuously hearing some background noise from others. A specific person who is not keeping on mute. I am not having a control here to keep that person mute also. I don't have the permission also here. The admin has it.
Hello.
Yes,
Yeah, hi. Vaibhav here from VLSIGuru. Just give me 2 minutes. I will make you as an organizer.
sure. Okay. We will continue in the meanwhile. So I hope you understood the flow of the VLSI. How does it looks like? We have different domains in the VLSI. Some part is related to design phase. Some part is related to the layout phase, and the remaining part is related to timing and also your tape out, which means giving the design to the manufacturing unit. Now, in this whole phase, why should I add an extra design? So I have clearly mentioned earlier, right? We need to, when you have a chip like this, when you have a chip which is already designed for the specification, I am continuously telling add an extra design here, which we call that as a DFT. So this is an extra design or this is an additional design which is placed inside the chip. Why do we need to do it? So if you don't have your DFT logic in the chip, what happens? Why can't we test the chip if you don't have the DFT logic? So we will see that in the next coming slides, what is meant by DFT, how it is important, and why it is used for testing. So imagine that the functional engineers has 20 years of experience, which means the person who is writing the code for the design for the chip has 20 years of experience, and functionally his code is 100% correct, which means he mentioned, right, I have developed the code and I'm very confident on the code. 100% I have written a correct design code which is required for the specification. But what happened? Imagine that the chip got manufactured and yet the chip got failed on the silicon. So silicon is nothing but, again, there is a manufacturing process. During the manufacturing process, we get this material called as silicon. It's a material that which where the chip will be manufactured. So while manufacturing, the the chip is not the same. Something happened in between. But yet the design engineer is telling, I have written a proper code that is 100% correct, that is 100% perfect, which should work for the specification what we have designed for. So there is a specification earlier, right? We have discussed it. For example, Bluetooth specification. So for this specification, he has written a code which is 100% perfect. He has 20 years of experience, but still the chip is not working properly. Even the code is perfect, the chip is not working properly. So what might happen? Why the chip is not working properly? There can be some manufacturing defects that can be present on the chip, which can be found only during testing. See, the design team told that I have written the code, this is my chip. Very good. But this chip will go for the manufacturing, right? So during manufacturing, there can be some defects. We do not know that because manufacturing is a physical process to form a chip. Manufacturing is a physical process to form a chip. So we do not know what went wrong during the process of manufacturing. So who is going to validate that? Who is going to test it? So there can be some manufacturing defects that can be found during testing. Even if your code is 100% perfect, but the chip is not working as per the requirement. So testing, using this testing process, we can determine whether the device is good or not. So you'll have a chip here. DUT stands for design under test. Design under test. Which chip, which design you are picking for the testing. So they will pick a chip. They'll start applying giving the values. They'll start observing the values here again. So what happened? They will see whether it is pass or whether it is fail. Whether it is pass or whether it is fail. If it is passing, then there are no defects while manufacturing the chip as per the code what we have. If it is failing, there is some manufacturing defect that may occur. So during the process of manufacturing, there can be some defects. What type of defects can be there during manufacturing? We'll see in the next slides. Because if I imagine this is my code is like an AND gate with a OR gate like this, and I'm going to a flip-flop. This is my code. A simple three instances, three elements I have taken: AND gate, OR gate, and flip-flop. So during manufacturing, there can be defects that can occur. Your code is proper, but the manufacturing is not proper. So we will see that. So are the DFT engineers are same as testing engineers? No, we are not testing engineers. We are trying to help the testing engineers mechanism. So what it will do, we have the chip, we add the additional design, which is nothing but the DFT is added into it. Now this chip will go to the manufacturing. Once it goes to the manufacturing, after manufacturing goes to the tester. There will be a unit called as tester unit. On this testing unit, they will start testing the chip. So a separate engineer will be there to test the chip again here. A separate engineer will be there to test the chip. Then what is our role? If there is a separate engineer to test the chip, if there is a separate engineer to write the code of the chip, if there is a separate engineer to manufacture the chip, so I have engineer 1 here, engineer 2 here, engineer 3 here. Okay, I have one engineer to write the code, one engineer to manufacture the chip, one engineer to test the chip. Then what is that we are going to do? We are going to add some extra logic into the design. So we also will be part of this point number 1. So we will be also called as designers, which means you are also designing something into the chip that may be later used for the testing purpose. So that is the difference between a DFT engineer to a testing engineer. So we are not testing engineers, we are different from them. As a DFT engineer, you're going to add some extra circuit into the design or extra components of circuit into the chip along with the RTL code, along with the very functional design code. So there can be some other manufacturing engineer, there can be some other testing engineer. They will utilize your code, they will utilize your design code, and they will start doing the testing. Okay, the question comes here. So which means DFT engineers are also design engineers? Yes. Are you going to implement extra design? Yes. So to implement this extra design, should I write the code manually? Not required. We are not going to write the code manually. We will take the help of that EDA, the design automation tools what we have, right? Using the tools, we will ask the tool to add that extra logic. So there is nothing like you have to write the code manually. You will ask the tool to write the extra logic into the design. So you don't need to worry very much, even if you don't know the Verilog in a very proper and good way, because you are not going to write the code. There will be an automated tool that will write the code. Then what is your job? You have to make sure the tool is writing the proper code and the tool is inserting the additional logic as per your requirement. As per your requirement. Okay. So once you add the design, it goes to the manufacturing. The testing engineer will utilize this for testing purpose. So we are not seen as test engineers. We are different from testing engineers. So in this course outline, there are many components which we are going to discuss. One of the first one is the architecture of the DFT. So architecture in the sense, what additional extra circuit you are going to add. What additional circuits you are going to add. Where the tool will be inserting, you will be not inserting anything. So there is a concept here called as scan insertion, compression insertion, and OCC. So OCC stands for how do you control the clock. So it is called as clock control unit. This is also inserted by the tool again. We are not going to write the code for that. These two methods are used to test the flip-flops and gates in the design. To test the flip-flops and gates in the design. Who is going to insert that? The tool is going to insert that. And there is another component called as memory best, mbest, which is used to for the testing the memories. Memory testing. You will have something called as memories. Have you heard about memories in the designs of electronics? You'll have something called as RAM. You might have heard about it. You have something called as ROM, right? Such type of memories will be there in the design. So for that, you're going to add some additional circuit to test the memories. An additional circuit will be added. Who is going to add it? Again, the tool will add that. You're not going to add it. Likewise, there is something called as JTAG and boundary scan. These are used for testing the chip inputs and outputs. Chip inputs and outputs. Because what if there is a manufacturing defect in the chip input and output itself? So for that, again some additional logic will be added. Who is going to add the additional logic? Again, the tool only will add the additional logic. The tool is going to add additional logic. So now there is another component here. There is another component here called as ATPG. There is another component here called as ATPG. So what is ATPG here? A test pattern generator. TPG stands for test pattern generator. It is going to write the test bench for you to test the data, whatever the circuit you have used. So it will activate the test circuit. Test circuit will be activated using the test bench, and we also validate them. The test bench will be validated here before giving them to the testing unit. So the overall concept of DFT is divided into these many number of subcategories. How do you test the flip-flops and gates? How do you test the memories? How do you test the chip inputs and outputs? So once you add this additional circuit into the design, we are going to write some patterns for that. We call them as test cases. We call them as test cases. Test patterns or test case. So this data you are going to give to the tester or testing engineer. You would select testing engineer. So the testing engineer will not have the data to what data they have to send into the chip to test the chip. We should only be responsible to generate the data and give it to them. So it is not only you are inserting the design, you're also activating the design and you'll give the values of ones and zeros which need to be applied on the tester. So what are that you're going to do? It is not only that additional circuit you're asking the tool to insert, you will be also giving the sequences of ones and zeros that require for the test engineer to start the testing. So that is how the overall DFT components are divided into. So these are the sum of the defects what we are talking about how does the manufacturing defect look like. So you see on the right hand side diagram what I have, right? So what does the right hand side diagram says? For example, if you see this part, the first one, there is break in a net connection. So there will be a what is meant by a net connection or a wire connection? A wire connection is between two elements, a gate or a flip-flop. So there is a break in the wire connection is a manufacturing defect. Or there is a break in between multiple wire connections, or multiple wire connections became short. One wire connection and other wire connection became short, or one wire connection is broken in terms of corrosion effects. So overall you can see here scratches or missing dark or missing wires, which means every net will be can be having a node also here like this. So what if this node is missing? Then the data cannot propagate from the left hand side to right hand side. So there can be some cracks also on this. There can be some crack also, which means the data is lost. You cannot send the data from the left hand side to the right hand side.
Excuse
Imagine there
me,
is an AND gate
the slides are not
and
moving. It is showing still we are in ASIC flow only. So are you showing something or
oh, is it so? I'm writing from past 15 minutes. Nobody has told me this. Very bad. Is it same for everyone?
now it is? Now it is okay. Now it is moving. Yeah, we are in course outline. Yeah, but earlier it was in ASIC flow only.
Is it same for everyone? Just want to understand. Let me reshare. You are able to see the screen now? Can you tell me which
Yeah,
slide you are seeing?
course outline. Yeah, types of manufacturing defects. Yeah,
Okay, this is
now
what
it
I'm
is moving.
talking
So
about.
earlier it was stagnant. Yeah,
Oh, I think I have explained too many things then. Let me go back and just revise. So after this ASIC flow, I have written here, like we have 20 years of design experience. I mean, the designer is trying to tell that they have written the code 100% proper, but as per the specification, but still the chip is failing. So they do not know why it is failing, because there can be a manufacturing defect that can be found during testing. So during testing, imagine there is a manufacturing defect found. So what is meant by testing I have written here. You have a design of an AND gate or an OR gate to a flip-flop, and you apply a data onto the chip. So DUT stands for design under test. So once the response is compared, we will try to see whether it is passing or failing. So we add the design. Are the DFT engineers are same as the testing engineers? We are different because we add a code into the design and we give the code to the manufacturer. The manufacturer, after the manufacturer, you have a separate engineer called as testing engineer or a tester, where they will perform the testing. So we are not same as testing engineers. We are different from them. Course outline, let me revise then since it is missed. So what I'm trying to tell here, I have some components here which are divided into different things. So the scan insertion and comparison insertion are used to test for the logic. An additional logic is required which is used for testing the flip-flops and gates, and it will be added by the tool. So that's why I have put an arrow mark there to make you understand it is inserted by the tool. Likewise, there is something called as OCC, an on-chip clock control unit. There will be a clock control unit on the device, on the design. Inside the chip itself, you have a clock control unit. So that is also inserted by the tool. We will ask the design. We can ask the tool to insert a additional circuit that can control the clock. So we'll have something called as memories, different types of memories like RAMs and ROMs. We have some additional circuit to insert to test the RAMs and ROMs separately. That additional circuit is again added by the tool. So likewise, we have something called JTAG and BScan. BScan stands for boundary scan. The boundary of the chip is tested. the boundary of the chip is tested individually. So the testing chip inputs and outputs separately. For that also you need an additional circuit to be added into the design, which you can take it from the tool. So there will be some standard set of designs in the tool. There will be some inbuilt circuits into the design where you can pick, choose, and accordingly we can add the additional circuit as per the requirement. So what is this ATPG? ATPG is a test pattern generator that can generate the values which are required for testing. So we validate them using a concept called as simulation, where we'll be having a test bench here. We'll be having a test bench. Using the test bench, we validate that in the software. Once it is validated properly in the software, we give this set of data to the testing unit so that they will apply on the tester. Okay. So how does the defects looks like? There can be a break, a connection broke, which is broke here. If you see here, that's what I'm trying to explain. There can be a wire connection, a metal is nothing but a wire connection here, or a net connection. So a wire connection is single wire connection is broken, or there can be a defect of multiple wire connections broken, or there can be a short connection of the wires. So how does a short connection looks like? I'm drawing in the bottom. This is an AND gate, and there is another OR gate, and it is going to a inverter here or a buffer here, and this is going to flip flop. What if these two nets got short? So we call this as a short connections. So this missing and dark and missing wires are nothing but related to the nodes. We will have something called as node, where a single net will be divided into multiple nets. So what if this node is missing in the manufacturing? While performing the manufacturing, this node is missed. Or while performing the manufacturing, there is a short connection. Or while performing the manufacturing, there is a breakage in the metal layer on the net connection or wire connection. So likewise, there are different types of reasons or factors that can cause a manufacturing defect. All these things cannot be checked in the code, because Verilog code logically tells the logic function will be of a chip can be described by a code, but the physical connection you cannot define using a code. You have to physically visualize the chip. So during manufacturing, different factors come into picture that can spoil the chip functionality. So in the software, using this extra circuit what we have, since our extra circuit is also there already present inside the chip, during testing, we will activate our extra circuit, the additional circuit, and we will start testing and see whether all these manufacturing defects are present inside the design or not. So how does your design or how does your circuit will perform this analysis? We also check logical performance only. So I'll show you how does we do it. So there are different fault models. Okay, before going to that, this is how the flow of DFT I have divided. First you insert the additional circuit here. You insert the additional circuit here, and you generate some test patterns. You do something called as patterns. We validate the patterns here. We do simulation on the software. Once this simulation is passed, then these patterns will be given to the tester. Once the simulation is passed, then we give these patterns to the tester. Okay. So the manufacturing defects are categorized into something called as fault models. The manufacturing defects are categorized into some fault models, like a stuck-it fault model. What is stuck-it fault model? A fault due to the node is stuck to either 0 or 1. A fault or a node or a net connection or a wire connection is stuck to a value called as 0 or stuck to a value called as 1. How does it happen? Same example, you have an AND gate, the output is going to another OR gate like this. But during manufacturing, accidentally or unknowingly, unintentionally, imagine that the middle network connection is short to a VDD value. Then what happens? This OR gate will always see a value called as 1. you will never see the operation of this junk of logic what we have in front of the AND gate, which means there is a clear indication of a defect here that is occurring. What is this defect? A short connection, to VDD power supply, a short connection to power supply, right? That is modifying your specification, because if it is already always propagating a 1 at the output side, what happens? The right hand side circuit will always see a value 1. You will never see the values which are coming from the B pin here of the OR gate. The A pin of the OR gate also is having very big logic, the AND gate inputs and all. Even that value is not seen, which means I can consider this as a defect. So this defect, logically we call it as a stuck at one fault model. The same example, imagine if the wire connection is having short to ground, then it is called as a stuck at zero. The wire connection is stuck to ground, then it is called as a stuck at zero. I'm mentioning again, these are unintentional connections. These are not intentional connections, these are unintentional, which means the design code does not has this, but during manufacturing it happened like that. This is not intentional connection, this is unintentional connection. The design code is not telling to short to VDD or ground, but during manufacturing it happened. So who is going to test it? Until unless I send some values here called as 0, 1, 0 or 1, 1 or 0, 0 something, then only I'll be able to validate and see whether this connection is there or not. So the manufacturing defects are divided into some fault categories here. So some of the fault categories which are related to manufacturing defect is this stuck at fault model, number 1, and there is something called as IDDQ fault model. Yes, you can consider for 2. There is something called as bridging fault model, which is called as 3. So this 4 and 5, gate delay and path delay, are not manufacturing defects. Those are related to delays. How is your chip looking in terms of testing? Whether it is having too very long delay or it is having short delay. For that also we can utilize this DFT concept to understand the delays in the design. So it's not only going to identify the manufacturing defects, it can also identify the delays in the design. So it works mutually for the benefit of both the activities. So what is faults due to leakage current? Every instance, like a gate or a flip-flop is built of some MOSFETs. The FETs actually what we have, transistors. A transistor may have something called as leakage current. When the transistor is in off state, still there can be a small current which can be flown, which we call that as a leakage current. So how many transistors you have in the design? We have lakhs, millions, billions of transistors. If every transistor is having a small leakage of current, it will accumulate for each and every transistor, and in the whole chip the leakage current can be very huge. The chip may burn also. So we have a different type of testing here called as IDDQ testing, which means a leakage current testing. We will see that this is also categorized one of the fault model what we have. And then we have something called bridging fault model. This I have just explained some time back. What if there is a gate and there is a short connection between two wires? We call this as a bridge. The earlier is bridging is short connection to VDD and ground. Now the short connection is between two net connections. What we have, it is not between two net connections. What we have. Okay, so likewise we have different fault models that are categorized. I have a good example here to explain you how the stuck-at fault will be looking. So you have an inverter here. This is the internal circuit of the inverter. So imagine there is a stuck-at fault on this inverter. which means this is the entire box of the inverter what you have, and the output is always stuck to 0. Of course, this is the capacitor actually. This is the capacitor what we have. So but there is a stuck at fault here, which means how does it look like? There is another short connection to the ground like this. So this is called as stuck at fault, stuck at 0. What happens? Whatever the value you give at a pin, whether a is equal to 0 or a is equal to 1, your y will be always 0, which means this is no longer acting as an inverter. Why it is? Because there is a short connection here to the ground. There is a short connection there to the ground, right? There is a short connection which happened for the ground. This is a short connection to the ground. That is causing this manufacturing defect. So there can be similar type of stuck faults as I have taken a simple example earlier also in the diagram. So there can be the stuck faults can be at what category, what locations? It can be either at the input or at the output of any circuit. It is not like always you will have at the input outputs only. It can be at the input any wire connection. So that's why it's written a line here. A line is nothing but a wire connection. A wire connection on any gate, input or output, can be fixed to a logical 0 or 1 and are independent of other signal values. So during manufacturing, we cannot suspect that always a specific gate only can be causing this issue. There can be millions of gates and transistors we have to suspect. So there are, so far we are discussing continuously, there are different tools, right? Like one for the insertion of scan, one for the insertion of clock controlling unit, one for the insertion of the memory bist, which is required for testing and all. So I have categorized here what all the different tools we have. So three different companies are providing the tools which are widely used in the industry. So each company has their own set of tools for the DFT operation what we want to do. So this is used for the memory testing. This is used for the flip-flops and gates. This is also for the flip-flops and gates, right? So likewise we have different set of tools from different companies. Overall, this is one company called as Synopsys. There is another company called as Cadence. There is third company called as Mentor Graphics. So in the institute, over the duration of the course, we are going to follow this part of Mentor Graphics tool, whichever I'm trying to draw in box. There is a concept called as synthesis. This is not related to DFT, but I'll be teaching it as it is interlinked to DFT. I'll be explaining this concept also as it is interlinked to DFT. We will see that. For this, we are going to use a tool called as Synopsys Design Compiler. And why did we pick these tools? They have better quality of results. So every company has good quality of results, out of which some tools has some importance, some precedence, some import in some more quality of results. So we wanted to prove the entire DFT flow in one category of two tools. So all these are comes under DFT. This is DFT concept, and all these also will come under DFT concept. Only thing which is synthesis is a different concept, not like DFT, but it is interlinked to DFT. So we will touch that concept also, which will be part of our course curriculum. So the labs, whatever we have discussed, the course outline like memory based testing, the JTAG, and then JTAG here is required joint test action group. It is called as joint test action group, which is a protocol actually. Action group have introduced a protocol. That protocol can be used for for testing the inputs and outputs. Likewise, scan insertion also we will see. This is called as compression, and this OCC is the clock control unit, what we have seen, clock control unit. And this is the ATPG pattern generation, the test pattern generation concept. Test pattern generation and validation. So we are going to cover all the course curriculum activities which I have discussed in the previous slides, except only one concept called as boundary scan. So this we are going to see theoretically only, not practical. Okay, because it requires some additional licenses and tools which we do not unfortunately have it at this moment. So we will see the boundary scan concept theoretically. Remaining all concepts, we have both theoretical plus practical sessions which are divided into some lab sessions. So the lab sessions I have divided into some levels of projects like level 1, level 2, level 3, level 4. So over the course period, we will going to see these 4 levels of projects. Each level may have again different test cases. Number of lab sessions can be some 6 or 10. Here you can again have some 6 to 10 lab sessions. In lab 3, you will have some 5 lab sessions. Here you'll have only 1 lab session. So level 4 is a master lab session that includes all the concepts. Level 4 is the master lab session that includes all the concepts. So that is how we have divided the projects or the lab sessions we have here into some levels. So we'll be providing some VNC access to you. You can practice during the working hours of the institute. We'll give some assignments also as usual. So the complete DFT flow will be on the industry standard tool mental graphics. So I have explained you 3 different tools here. No, 3 different tools are there: Synopsys, Cadence, and mental graphics. So out of which we are going to see the entire flow with mental graphics. A dedicated mentor will be available to clarify your lab sessions doubt. So here lab sessions are different from your practical explanation. So I will be taking the theory class plus practical explanation. So explanations will be by me only. There will be no other people who will be coming and doing it, right? Explanations will be by me, both practical and theoretical. Lab session is something like a live session where you are going to sit, a mentor will be there, a industry experienced person will be there. They will be online for you who are juniors to us, and they will be available online. During that time you can start doing practicing on your own. If you have any questions, a live debug or a live support will be there for you on the weekends or weekdays. Of course, if you are stuck with something or if you need some explanation, some clarification, anyway, we can discuss them with our regular classes. So that's what I have written here. We can discuss them during our regular classroom sessions also. So there will be some backup classes also for missed session, but this is limited. This is not like you'll be getting every week. This is limited. Like once in a while you are not able to attend the course or the class session, you have missed some topic. So once or twice or thrice maximum, they will be providing you some backup classes which are required. So a WhatsApp group will be created for each and every batch where we'll be discussing the questions, queries, doubts, or timing sessions of the course or the weekend class sessions, assignments, whatever it is. I'll be sharing the materials using the Google Classroom. I'll be creating a Google Classroom for every batch. It is a lifetime accessibility. There is no validity on this. We will not delete it. Okay, there is no validity for this. You can use it for lifetime. Whenever you have access to my link, you'll be able to do it. So from past 4 or 5 years back, students are also still able to access my materials now. So the documents related to tool commands and procedures also will be shared via the Google Classroom sessions or using the WhatsApp group, whichever it is convenient based on the requirement, right? We can either share them in the WhatsApp group or we can share them in the portal what we have, or we can share them in the Google Classroom. However, it is feasible for the candidates, right? We can provide the share the materials accordingly. So I'll be able to answer your calls also. If you want to speak to me, you can call to me during this particular slot, evening 5 to 7 every day, apart from the weekdays, weekends. Because anyway, weekends we are going to discuss. We are going to spend some quality of time to understand the topic and discuss the topic together. Apart from the weekends, weekdays like Monday to Thursday. Of course, Friday is holiday at the institute. So Monday to Thursday, you can call me anytime. Of course, I'll be available on Friday also. There is nothing limited for you. So you can reach me anytime during the weekdays also during this particular slot. If you have any questions or queries or you're not able to understand something, you need some one-on-one session where you want to get some questions, doubts clarified, you can still reach out me at this particular time slot.
One query here.
Yeah.
So if we attend only the weekend classes, okay, will it
Uh-huh.
be a live session or it will be a recorded session?
See, there are no, it will be my sessions will be on weekends only. Are you talking about weekdays or weekends?
Weekend.
Weekend, I'll be there. During the weekend, I'll be only explaining the
Okay.
sessions. The Saturdays and Sundays,
Okay.
I'll be
What
taking the
about labs?
classes.
Lab sessions is also there on weekends only?
It is on both. I mean, on Saturdays and Sundays, the first half will be the explanation of the theoretical. On the second
Mm-hmm.
half, where you can do practice on your own, but my
Okay.
explanation of the theoretical and practical will be in only the first half of the session. Okay. The
First off.
lab live
Okay.
session will be also available on Saturdays and Sundays, weekends, second half. Apart from that, you
Mm-hmm.
also have the lab sessions on Monday to Friday based on the batches.
Okay. Monday to Friday, it is only for labs, right? So your
Yes,
explanation and theory classes will be there on weekends only.
yes, that is true.
Okay. Got it. And I have seen in the curriculum that so some tickle scripting also is there. So are you going to take that as well? Or?
No, ideally it's an open source, um, you know, details. We generally, I mean, there'll be some brush up sessions where there'll be another trainer who will be giving some introduction about the skills which are required, like this Verilog or Perl or Shell Tickle, whatever it is. I will be explaining the part which is required and related to DFT in one of my sessions. I'll not go
Okay.
extensively into it. Not we won't
Mhm.
explain about the automations and all, but the basic skills which are required for utilizing the commands and switches which are related to the tool, yes, we will be touching them.
Okay. Okay. Thank you.
Okay, so going forward, let me go to the next slides. So after the lab sessions, so support from the students also have covered. So job opportunities, we have different tie-ups with the various companies. So students will be supported to the placements based on their assignments and the performance. So we have some mock interviews also that can help the candidate to push themselves to understand how does a real-time interview looks like. If they are not attended, at least few people may attend already, but few people may not attend based on their current situation. So even a person is already experienced the interviews, yes, if you request for having a mock interview, we can still arrange a scheduled mock interview from the candidates who are already working in the industry, because many previous students have got placement and they are working in different companies, so they can spend some time over some weekends to take a specific mock interviews. We'll be providing the previous interviews questions and preparation also. So most of the things I'll be covering in my course. Whenever I specifically target a topic, I'll be stressing and pointing it out. Okay, this is how the interview point of view will be there. Post my explanation of a topic, I will try to stress on that and tell that okay, now you understood the topic. Now there is an interviewer who is coming and into the picture, and how does their view of point can be there, and how do they project a question to you. So you should be ready to answer them. So we'll most of the times I cover them during my course duration only, but we can also provide a separate documented a list of questions also from the previous interviews. It's a very small industry, and in the VLSI, the DFT also plays a very important role. I hope you understood what is DFT by now. So we try to identify the manufacturing defects. Further, we add an additional circuit into the design, and we generate some test cases and give it to the tester team. So they will validate and see on the tester whether if there are any manufacturing defects or not. So we are not test engineers; we are different from them. Okay, so DFT is involved in both front end and back end. So why did I mention this specific point? Let me go back to my previous slides of the ASIC flow, what I have mentioned. So if you see the ASIC flow here, up to here, it is called as front end. Here it is called as back end. So where is DFT in the back end then? Yes, we will have in this sign off, in this so-called sign off, along with the timing and performance, we have that concept called as ATPG, the automatic test pattern generation. So little bit part of the, and we do also do the validation also, the simulation and validation. It's not just you are inserting the design, you are writing some test cases using the tool and you are validating them. So some part relies in front end and some part is in the back end. So back end is something like layout and other validations comes into the back end. Your designing part always comes in the front end for any chip. Okay. So it's a very basic introduction of the demo which I would like to give you a clear picture of what DFT stands for and where does it sits or plays an important role in the entire flow of the ASIC flow for making the design implementation for the ICs. So you're ready to start the course. I wish you all the very best. Hope to see you again in the regular classroom sessions. If you have any questions or queries, you can, we are open for discussing them. You can enable your mic or speak to me, or you can type your questions in the chat window also. Anything is perfectly fine for me.
Yes, sir. I have one doubt.
Yeah, tell me.
Yeah, front end means we need to write the program. We
Correct?
need to write the comments.
Yes.
So,
But here in the DFT, yes, you're right. It's not program, it's called as code. Program is always different
code.
between code. Code is the
Okay.
logical operation that tells. Program is a
Okay.
software language that tells.
Yeah. Yeah.
So we are
Okay.
in
Okay.
the designing part, we tell it is code. Yes, DFT, some part, majority of the part of the DFT comes into the front end, which you see on the screen, like the scan, insertion, compression, the clock control unit, memory testing, logic, wherever I have mentioned something called additional circuits. But I have put everything an arrow mark redirecting to a top line called as tool. So tool does this on behalf of us, where the tool will write the piece of the code for us. You need to instruct the tool. You need to play around with the tool. You need to get your hands dirty with the tool and make sure that you get the operation is getting completed. So that is a part of DFT engineer in terms of the architecture and insertions.
Okay.
Okay.
Thank you, sir.
We are not going to write any code manually.
Do we have
Okay. Thank you, sir.
LBIST insertion as well here?
We are not covering the LBIST. Theoretically, we cover the LBIST, but we are not going to cover the LBIST in this particular course. Yeah.
We need to write some scripting also, no?
Yes, there will be some tool commands and tool instructions which are required. So if you understand the tool commands and instructions, scripting is not mandatory. It is always better to learn and it may help you in different aspects. So for example, I'll tell you, I inserted my design. I want to see how many AND gates are there in the design. I can't simply open the code and count one by one. Okay, and get 1, 2, 3, 4, 5, 6. Imagine if I learn some scripting, it will be easy for me to quickly get the response and see how many number of AND gates are there in the design. So in those perspectives, we use the scripting. But of course, the tools are also built based on the scripting languages only. So minimal scripting language is good enough to understand this entire course.
Okay. Thank you, sir.
Okay. Yeah, I heard, I think another question, someone else is trying to speak. Let me know what is your query.
Hey sir,
Yeah,
I have a question.
yes.
In our labs, we can insert scan chain by two different flows, which means scan chain implicated by different EDI tools, depth
Are
compiler
you,
or tessent.
yeah. So if I'm not wrong, are you speaking about this slide where I have mentioned two different flows?
Oh, okay. Can you hear me clearly
Okay.
now?
So we use mentor graphics tool only. If you see this particular table, a scan insertion, we are going to use mentor graphics, a Tessent DFT advisor for implementing the scan chains. The connectivity of the scan chains in this institute will be performed using the mentor graphics tool. Okay, but why did I mention two different flows is very specific because um, it comes in a component of the compression or also called as EDT insertion. So if you see there is a next commercial component here, what we call as compression insertion. This is also correlated to scan insertion. Okay, so both these concepts together combinedly completes the scan insertion. So how do we this do complete this? Whether should I do the scan insertion first and do this compression session next in an order, or it should be a vice versa. Imagine I would like to perform the compression insertion first and followed by I want to do the scan insertion last. So that's where my intention here is to tell you two different flows we follow in scan insertion in choosing the scan and compression when we want to perform. Did I answer your question?
Uh, it's only use matter editors.
Yes, yes. We use Mentor EDA tools, which is Tessent DFT Advisor, which is there on the screen. If you're able to see this
Oh,
here, try
okay.
to zoom.
We
Yeah.
we don't use depth compiler in synopsis.
Um, we go for a recent method of mentor graphics, which we call that as TSDB flow, Tessent Shell Database Flow. So if I go with the Tessent scan insertion, it is easy for the flow explanation where how to read the collaterals from one tool to one step to other step. Like how do I get my embist or EDT inserted data into the scan using in terms of simpler forms. So we targeted the mentor graphics design tool only because overall, if you take in the industry, 70% of the companies use mentor graphics tool. Yeah, but there is optional, accountable here. Some people may use synopsis tool. Some people can use mentor graphics tool. If you know the methodology, it is not that difficult to use the tool. See, these are automated tools that follow your instruction which implements the design or just insert the design. Whichever the tool you pick, whatever the concept you pick, the methodology is still same.
Okay,
Did you
okay,
understand my
thanks.
point? Yes. Okay. So imagine I want to stitch the scan change using DFT advisor. Yes, it will still do it. If I take DFT compiler, yes, it is also going to do the same fashion. Of course, little bit cures, the quality of results may be little different. But yeah, at this moment, I would suggest when you start learning something, any tool, if you start learning, it should be not that difficult to convert it into another tool operation. Am I clear to you? Okay, good. Any other questions from or queries from anyone else? So this is just a demo introduction session. I'm not trying to focus too many number of things. We will get more detail into the concepts when we actually start the regular sessions. Okay.
Sir, when it will be going to start the regular sessions?
It should be starting this month, so we can, probably reach the admin. They will have the schedule of starting the new batch. I think they have already started a new batch, like 2 3 weeks back, but still, it is the actual DFT course hasn't been started. So we have just only the brush up sessions for the first 2 3 weeks, where different mentors come, different tutors and mentors or trainers comes and give some basic introduction of VLSI or your digital design and Verilog and scripting. So maybe that part is currently going on, according to me. So around in another a week or 10 days, we would be starting the actual new batch for this DFT course, the core DFT. Okay.
Okay, thank you, sir.
Yeah. Any questions from anyone else?
The e-learning course is the same as uh, a live course.
Online. A little different it will be. The interaction between you and me will be little not that frequent. E-learning course is something like my previous batch recorded videos where you can, it's like an online library. A recorded video will be there. You can learn on yourself, self practice and self individual learning course. But interaction with the trainer with me will be very limited. Once in a while we'll be available for, basically declare for clarifying the questions and queries. So you will be not getting a complete live session to get your all questions and queries clarified every week. So that is how the basic difference will be there between e-learning and regular course, the online course, the live session. Okay.
Okay.
Yeah. Okay, good then. Nice speaking to you guys. So I hope we'll be meeting again in the upcoming duration of the class sessions what we have. See you then. Thank you for your time.
Yeah.
So yeah, okay. I'll be closing the session for today. If you have any questions or queries, you can reach to the admin team what we have here. They can clarify your doubts and queries. If anything still you have related to technical, you can reach to them. They can arrange a specific call also where all your questions and queries will be addressed. Thank you. See you. Have a nice
Thank you.
day.